These days, we've become perhaps too familiar with the wide-reaching effects of climate change on everything from human health to weather patterns. However, a thing often overlooked is the indirect consequences of these effects on habitats other than our own. With natural disasters and pollution on the rise, animal species across the globe are currently having to adapt and survive in some of the most extreme and unnatural conditions to date. Frog species are no exception, especially during their most vulnerable life stage as a tadpole. Tadpoles are particularly susceptible to illness and even death for a variety of reasons. To start, tadpoles emerge from jelly-like exposed eggs that their mothers lay en masse in bodies of water, leaving them somewhat defenseless against increasing aquatic pollution. During this next stage as tadpoles, many developmental milestones occur that ensure the survival of these future frogs, all while their skin is still quite permeable to the environment. A pollutant of concern for tadpoles in North America, what with increasing runoff, is the leaching of road salts from urban areas into local bodies of water. Road salt usage during the wintertime has increased drastically in the last 50 years, leaving experts concerned about runoff in local watersheds. In prior studies, it has been found that unnatural salinization of tadpole habitats leads to higher predation rates, slower burst speed performance, and developmental and anatomical limitations. In this study, I aim to analyze the impacts unnatural salinization has on a newly discovered tadpole defense mechanism, switchbacks. Switchbacks occur when tadpoles perform 180-degree turns while actively swimming, potentially turning towards a predator or other stressful stimulus. Switchbacks have not been widely studied, so we decided to further the limited research regarding this unique aspect of tadpole defense. Prior to experimentation, pegorel frog tadpoles, otherwise known as Lithobates palustris, were collected from Assunpink Wildlife Management Area in Monmouth County, New Jersey, from May 14th to the 17th of 2020. Experimentation occurred outdoors due to the constraints of the pandemic. In our study, tadpoles were exposed to a control in 3 different levels of salinity: 0, 0.05, 0.1, and 0.2 molarity of NaCl. After an acute 15-minute exposure, the tadpoles were forced to swim in an O-shaped apparatus for 3-minute trials, and the number of switchbacks were counted. Tadpoles were gently prodded with a rubber spatula after each 5-second interval of inactivity during the trials to both provide a stressful stimulus and encourage continuous swimming. An ANOVA test and Tukey's post hoc test were used to determine the statistical significance of the results. After analysis, we found that only 2 of the 6 salinity level comparisons, switchback differences were statistically significant: 0.05 to 0.1 molarity and 0 to 0.2 molarity. These results imply that salinity may have some impact on tadpole defense mechanisms, but further experimentation is needed to determine the extent. Future experimentation would benefit from performing a MANOVA analysis, testing whether switchback count and lateralization are correlated, and adding additional salinity levels. Special thanks to Oscar for our funding and to Dr. Tina Bell for making this project a reality. Thank you for watching.